You can't like upload your own graphics. It feels unbalanced. I'm paying for it.
नहीं है मतलब ठीक है हाँ मतलब उनमें वो ठीक है मिनिमम जा सकता है
I don't know. They're very limited. Aries, which I don't care about. I keep seeing it because I have to go to.
All right. So let me see. I think we have to unmute here. All right. Hello, hello, hello. Can you hear me? All right. So good afternoon, everyone. So today we have, as part of the seminars, we have a special seminar, not only for the speaker, but also because this is jointly organized with the IABSE, International Association of Bridge and Structural Engineering. In fact, we are doing an hybrid mode, and there are people connected internationally, mainly from the US. So before starting with the presentation and the technical contents, I will go through very quickly about IABSE, and this will be very helpful for you because there are good information, especially for young engineers. So IABSE stands for International Association of Bridge and Structural Engineering. And the mission is to exchange knowledge and advance practice of structural engineering worldwide. I have to say that I am also a member of IABSE. It was founded in Switzerland, and is more than 90 years old. It's one of the first structural engineering association that started in Europe, and since then it grows exponentially. And every year they had several activities, which are not only related to. Sorry, I'm always struggling. Are not only related to conference and the symposiums. They usually have one symposium and one congress per year, but they also have a lot of webinars. And for example, they had just a symposium in Manchester, and in September there will be the Congress, which is the biggest event. It will be in Costa Rica. It's not far away from here, so you may think about that. And so this is the advertisement for the Congress in Costa Rica. We also have, as a group, US, we have some activities plans for that event. So there are a lot of technical commissions. There are 40 task groups, and it goes through performance and requirements, conceptual design, structural analysis, construction methods, existing structure sustainability. The association started around bridges. In fact, it's called the International Association of Bridge and Structural Engineering, but also covers a lot of aspects related to structures which are not just bridges. And these are examples of reports that those commissions produce. So that basically each committee has the objective to produce something which is going to be useful for the profession and the research community. So Young Engineers Committee is probably what you guys are more interested. Basically, the good thing is that you have a student membership. You have free online access to the journal, which is very good because it's the Structural Engineering International Journal is a mix of research and actually practice. So there are good projects actually to go through. There are monthly newsletters, and then the good thing is that you are part of a network, so the platform is pretty good and allows you to connect with other international colleagues. You also sometimes you are assigned to mentors, and these mentors could be fellows, so which are experienced or seasoned members that help you with guide you through your career. So this is quite a good program. You have to be under 35 to be eligible. Most of you probably are eligible for this. Otherwise, you will go into the general category membership type. Okay. Sorry, I'm not very good with Microsoft. And these are example of activities. I think, you have to think about that, sooner or later you will start your career professionally, and you need to think about what are the good associations for you. I mean, obviously there are a lot of American associations, but this one has the peculiarity to allow you to connect outside of the US, because it is an international association, but as obviously the headquarters started in Europe or in Switzerland. IABSE in the US. This is the board of directors. The chair is Maria Grazia, Italian. You will see there are more Italians than Americans in the board of directors. I don't know why. So, we are actually meeting, and they drag me in as well. But we are meeting monthly and try to organize activities, webinars like this, in order to keep connection with the profession, but also with universities. And these are the activities. What will be usually we have also a national group conference is one day, and we also try to organize a very good site visit on a particular bridge which is under construction. And as I said, we also provide the quarterly newsletter. I think this is pretty much about the IABSE. So please have a look to the website. Feel free to email me if you need any information. And one of the things that I wanted to do as a member, I said we will need to have more activities where we as association go into the universities and try to stimulate the next generation of engineers to be part of the association. And that's why when we start thinking about, we should have a very good start, so we should get a VIP speaker, and so we came up with Gernot, Komar, and he's originally from Austria, but he lived in San Diego for many years. He actually lived very close by, so it was very convenient for him to come as well. He graduated at the Technical University of Graz in Austria, and he has over 30 years of experience on design, analysis, segmental constructions, erections, and also managing of large projects. He's also a board member of the UC San Diego Industry Advisory Group, which is a quite important role for us because the board provides advice to our department. And he's going to talk about an amazing project, which is the Hal-Shindaga corridor with Infinity Arch. You have already seen the picture. The bridge is spectacular. So without any further ado, I would like to have Gernot to talk about this amazing bridge. So thank you. Yeah, Gernot is also a very good soccer player. So, by the way,
thank you.
So, we haven't talked about Italy and Austria. We had several recent matches that went well for Austria and went well for Italy as well. But yeah, I know that.
Normally we lose against Italy.
No, but last time you won. So
we always look back just to the last game.
All right, I think we should be.
I think on here at home or on Zoom, they can see the, not the presentation mode, they see the overview. So let's see if this works.
I hope it works this time. If not, then I apologize for the inconvenience because you can also see the small screen. Should not. Actually, this is the broadcasting screen.
This one, yeah.
Yeah, this one as well.
Yeah.
For some reason.
Let me see if I can move this a little bit. No, I can't.
For some reason.
No, it's fine.
Yeah, if you want to hide it, you can just then you have to go to non-content.
Let me move this a little further over, then it doesn't matter. Okay.
Okay, let me try.
Maybe I need this. Then they can see it. No,
This,
at home they cannot see this one because they see also the frame.
Okay, now I move this side. Hopefully, they can only see this.
I don't think so. Can you move it back?
Okay.
You guys here are fine, but it's just for the people on Zoom.
This, doing the hybrid always create challenges. So sorry, be patient.
We don't need to see the screen, do we?
Oh, you mean this one?
Yeah.
This one's always there.
Okay. Okay.
Yeah.
Okay.
Sorry about that.
No worries. Good afternoon, everyone. Today I want to talk about the improvement of the Arch-Indagwa corridor with the Infinity Arch and with precast and cast-in-place segmental bridge in Dubai. And I say this is the best of both worlds of segmental bridges in concrete. We have precasting and cast-in-place. Here are the necessary slides to get the PDHs. I will skip this. Copyright material. Purpose of learning objectives. At the end of this presentation, you will be able to be knowledgeable about the design and construction of cast-in-place and precast segmental bridges. Learn about the cast-in-place balance cantilever, segmental bridge construction, and learn about short line match casting and precast segmental bridge construction. The agenda for today: first I will give you an introduction and a general overview. Then I talk about the cast-in-place segmental bridge, the Infinity Arch. Then the precast segmental bridge, bridges on Cornish Street, and a summary. First, the introduction and the general overview. Dubai is an amazing place. It's changing every day almost. And you see the project location. It has the Palm Islands, it has the Walled Islands, and has numerous Guinness Book records, like the tallest building, the Al-Khali, I don't know the name yet now, sorry about that. Over 825 meters, it's more than 2,000 feet, has the largest indoor mall. Within the indoor mall, it has the largest aquarium, the largest and longest ski slope, and they have also the fastest police cars with over 250 miles per hour. That's a Bugatti. I will zoom in on the project location and talk about the cast-in-place segmental bridges with the Infinity Arch over the Dubai Creek, and then about the 21 precast segmental bridges on Cornish Street. Here's a general layout of the improvement project. The cast-in-place segmental bridge on the southwest side with the Infinity Arch and the 21 precast segmental bridges over Cornish Street. The rendering shows the Infinity Arch Bridge And I want to point out the pedestrian walkway that's on the south side. Let's go back. Where they have ramps on there on the bottom left corner in order to get over the Dubai Creek. And then further on to the northeast with the precast segmental bridges. And again, you get on and off this bridge with ramps and with elevator. Now talk about the cast in place segmental bridge and the infinity arch. The general layout and the cross section. It's a 300-meter long cast in place segmental bridge. Actually, there are two segmental bridges, and each of the segmental bridges, they have two box girders. And the infinity arch, I want to zoom in a little bit. It's a very unique architectural feature. It's a steel structure, this infinity arch. And the two cast-in-place segmental bridges cross a very unique area. It's the Dubai Creek. The maritime traffic is very heavy in this area and needed to be open during construction. It's an ancient area of the city, and it's very well received, of course, and it's a getaway or getaway into the Dubai Creek. Again, it's the modern design is just striking and very unique. The structural type, it's both tensioned concrete box girder structures, and the span arrangement is 80 meters, 135 meters, and 82.5 meters. It's close to, it's 297.5 meters, which is about 900 feet long altogether. The navigation channel itself is 75 meters wide and 50 meters tall. And the infinity arch as the architectural feature supports the pedestrian walkway. And the 3.5 meter wide pedestrian walkway is supported off the edge girder on the south side. The bridge width overall is 26.4 meters from south to north, and from north to south changes from 26.4 to 29.3 meters. It's about 90 feet. It's a very wide structure. It carries on each bridge 6 lanes of traffic. So overall 12 lanes of traffic, which is tremendous and will help the area to move the traffic faster. The superstructure depth is 7 meters over the piers in the center and changes from 7 to 3.5 meters at the center of the span and at the end spans. The height of the infinity arch, the maximum height is 42 meters for the top arch, and for the lower arch is 38 meters. The Dubai Creek is a very busy recreational and commercial navigation channel. During constructions, it needed to be kept open, which was also very challenging, and restricted also the construction method. And the construction for that, for the superstructure and also for the pier protection system took about 24 months. Talked about the navigation channel. As you all have heard about the terrible collapse of the bridge in Baltimore, Maryland, it is very important to have a pier protection system. And this was also implemented right from the get-go so that no ships or vessels can impact the piers, which was also in the water. Here the protection system and final configuration. The structural analysis model for this bridge, we used a 3D analysis model with Midas Civil, and we used it for the design of the cast-in-place segmental bridges, for the infinity arch, and for the precast segmental bridges. The model consists of all the construction stages for the balanced cantilever structures, as well as for the erection of the infinity arch and the impact of the erection of the infinity arch onto the balanced cantilever structure. We considered all time-dependent effects and also all the stressing procedures. I mentioned already the cast-in-place segmental bridge had 2 box sections for each bridge, and they were connected with rigid links. And the walkway, the steel structure on the south side was implemented to the Midas model and was supported by the infinity arch and by the edge girder. The arch was also used to stabilize the bridge under high wind conditions. The plan view of the model, the design code we used in Dubai was the AASHTO LFD, the 7th edition, and considered grid and shrinkage and steel relaxation based on CBF B90. Then concrete material, C65, C6 for the superstructure, C64 for the substructure. The BT strengths, 270 grade. The structural steel, grade 50. The rebars, 60 KSI rebars. And also for the stay cables, 270 KSI were used. Timeline was very important for that structure and actually drove the project. And the cast-in-place segmental bridge with the infinity arch, the contract was awarded in May 2018, and already in June, in November 2018, the cofferdam work started with all the substructure work in May 2019, all the piers, the pier protection system, and it took about 10 months to finish it. The form traveler were installed in between from January 20 to March 2020, and the superstructure finished in December 2020. And then the steel arch the work on the steel arch started in December 2020, finished in August 2021. And the bridge opened on 16th of January 2022 by the Sheikh Mohammed. It was a big celebration. The pier, the substructure, and the center piers, the 4 center piers, including the pier head, it took about 5.5 months. Every pier was an average 22 meters tall and were erected or casted in 4 lifts. And it took about 2 months to install 16 form travelers. 16 form travelers is what we'll see later how this looks like. And of course, all the form travelers were load tested, which is a standard requirement. Here's a view of the balanced cantilever structures under construction. And you can see already the 4 box girders for the 2 bridges with the with the 16 form travelers. You see 4 on this side, 4 on the other side of the balance cantilever structure, and the same on the other side. It was very challenging during COVID to get this going so fast and have also the right workforce available. We had 320 cast-in-place segments, and it was completed in 10 months, including all the closure bores. So a cycle time of about 10 days was achieved, and we were able to reduce it later on to 6 days. The length of each segment was 3 meters, and it was very challenging with the resource loading to get the workforce on there. The question was how to place the concrete, and of course it was a staggered operation. So we had work teams of 20 workers, 16 work crews with 20 workers, with fitters, carpenters, operators, etc. And they were working always overlapping. So the process is you have the form traveler on there, you place the form traveler, then you need to get the rebar crew out there to place the rebars in the form traveler. Then you start pouring the concrete, come back with the inner forms. Then you finish the pour. Then you insert the post-tensioning. You start after it's hard and cured, you start then the post-tensioning operation. And after everything is in order, you are able to move the formwork further to the next step. And this all needed to be organized. So we couldn't pour the concrete all at the same time. So we needed to start pouring concrete for one of the sections, then next day for the next section, and so on. We had 16 different locations where we needed to place the rebar, pour the concrete, put in the BT stressing, and then move the form traveler. So the crews needed to be coordinated, and there was a good collaboration. It's a very, very wide structure. The structure is 26.4 meters wide times 2, and for 12 lanes of traffic. The concrete placement was done mostly during night, when at the maximum temperature, you can imagine Dubai is pretty hot. So the maximum temperature during the night when the concrete was poured needed to be below 35 degrees Celsius. So it's close to 90. And we also performed the geometry control always in the morning, where the average temperature was about 30 degrees Celsius, because then the movement of the cantilever arms was always the same, it was controlled. The closure bore 1.5 meters, and I mentioned earlier the segment length 3 meters. The infinity arch itself was fabricated in your home country, in Italy, northeast of Italy. It was then finalized and assembled in Dubai. There were 46 segments. The overall weight of the infinity arch was 2,500 tons, with an overall height from all the way to the bottom, 67 meters to the top, with a length of 135 meters. And it was shipped from Italy to Dubai, and the steel segment were then transported to the site using SBMTs. And then the segments were lifted with 600-ton crawler cranes on barges. The longest segment was 41 meters long and 100 tons heavy. Okay. So the placement or installation of the infinity arch, the first steel segments were lifted and embedded in the rebar cage, and then cast into the piers, and then built all the way up to the deck level. Then the deck was finished. Later on the deck or around the deck, we had 4 towers in the water, and then 5 towers, 35 meter tall, on the deck of the balance cantilever structure. And they were all construction stages, and sequence was checked, and the deck was checked to make sure that all the service checks and strength checks were fulfilled, and the structure is sound and safe. These are the construction sequence with the last segment brought in, and then arch were finished, and the final segment, the tolerance, was only 20 millimeters, less than an inch. Well, VSL installed the stake cable for the arch, where 46 cables were installed, and took about 5 weeks for the whole process. And here the stressing procedure with the VSL professionals. Also for that structure and for the cable system, a maintenance system with a robot was installed with a magnetic NDT machine with separate laptop, which will also detect internal and external broken wires, corrosion, grooves, and notches. There were 4 visual inspection cameras on that machine, which detect external defects. And then this machine also had brush for cleaning the HDPE pipes. I want to give credit to a lot of contractors on this one, and of course the owner, Road and Transportation Authority in Dubai. The designers are Parsons, a contractor for the casting place segmental bridges, where Besics Group Middle East is a subsidiary of Six Construction. Then Parsons did also the construction engineering services and inspection. The form travelers for the segments were from NASA Structure in Australia. The same with the Bose tensioning system. The bearings from Mageba, it's also a European outfit. Pre-packaged grout from Sika. The Infinity Arch from Mike, SPA in Italy. And the stake cable from VSL Middle East in Dubai. Let's move on to the precast segmental bridge on Cornish Street. For this one, here's again general layout for the precast segmental bridges on Cornish Street. We had 21 precast segmental bridges, and then also 3 cast-in-place bridges. For the section variations, it was easier and cheaper to get cast-in-place bridges in there. For all the other bridges, we used precast segmental. I want to focus on one of the bridges. It's the main north-south 3 and main south-north 3. This is a typical structural layout with a span length of 34.6, 2 times 50 meters, and 34.6 meters. The bridge width for all the precast segmental structures were 26.3 meters with a 1 foot or 0.3 meter stitch. And again, of course, 6 lanes of traffic in each direction. The overall depth of the structure was for the precast segmental structures 2.5 meters. The segment length 3.1 meters. I want to focus again on these structures on the north-south and south-north, and then separate the outer north, the next one, and so on, because we needed these structures to model for also for the geometry control. And they were, we used this for the entire construction stage analysis and also for independent design check of the designers. And here you see color-coded the different segments for the precast segmental layout, because the segmentation needed to be precise, and we have starter segments, which are end piers and the pier segments, then the balance cantilever segments in green, and then also the span-by-span segments based on direction method. Geometry control of the short line match casting. We used the short line match casting for the precasting, and geometry control is very important component for precast segmental bridge technology. You can, with the short line match casting, you can form any structure, any layout, any alignment, vertical curves, horizontal curves, and also change the soup elevation. The geometry is defined for every precast segment in the precast yard, and every segment is unique. You cannot interchange one segment with the other. It's match casted to each other. It's like a jigsaw puzzle. We used for the geometry control a total station with a precision of 0.6 millimeters, and the geometry control accuracy in the precast yard was less than 2 millimeters. Here, the short line match casting, the general concept. On the left, this is the fixed bulkhead in the back, and then the side forms, the inner forms, and then the sliding table. On the right-hand side, you see the different segments that were already produced. The first segment in the front is the segment ready for the storage area. The next behind is the segment ready for batching. And then this is the match cast segment, which will be used as I said, match cast for the following segment, for the wet cast segment. So after this is cured, you take out the forms, you push everything out, you take the match cast segment, will become the segment for batching, and then the wet cast segment will become the match cast segment, and so on. So you produce slice by slice, and everything is cast together. It matches. At the bottom, you see the processes again, with on the left side the form with the sliding table. The second in the middle shows the segment cast, and on the outside segment on the right side, the segment for the precast yard, for the storage area, and for the batching area. The short line match casting workflow. Everywhere and every time you need the geometry control for the installation of the fixed bulkhead, then for the positioning of the floating bulkhead or the match cast segment, then of course then the installation of the rebar cage, then you pour the concrete and you let it cure, you put in your markers, then the precision survey of all the precast markers, and finally you, after everything is done, you shift the segments in the storage area. We used a product where we had a precision survey. Everything was automated. So we had a survey app. The survey app had all the data for each segment. It was transferred to the total station, performed the survey in the precast yard, and after the survey data were given back to the platform, processed, QA/QC control, and then sent back to the surveyor to give them an okay to go to the next segment with all the correction of each segment. So this whole process is completely paperless, and we were able to perform all the geometry control remote. So the geometry control team was not on site. We did not need to be there. We had only our surveyors there, and they sent the data. So we processed the data in the United States or in China, wherever you are, and then you send the data back, and then they can start over with the next one. It really helped to reduce the workforce on site during COVID. Well, timeline again. For the precast segmental bridge on Cornish Street, this contract was awarded a year later. Started April 2019. Starting with the substructure work, which was a heavy lift with 21 bridges, all the piers, the band caps. It took almost 2 years to finish this. The assembly of the 2 launching gantries started in February 2020, finished in September 2020, and was also load tested. The precast segment production started in May 2020 and took about 10 months, a little longer, over a year and a half for the casting of the or fabrication of the precast segments. We had 1,900 precast segments, and the superstructure work, the installation is pretty quick actually. From November 2020 to October 2021, it's about 12 months. And the bridge putting up the finishing touch up to January 2022. And again, big surprise, same date. Bridge was opened in January by this Sheikh Mohammed. The precast yard itself, we had for the precast yard in the front, you see the storage area, and on the right side, one of the gantries on rail, then one of the cranes on rail, then one of the bigger cranes or gantry cranes. The stations we had on the very left side, right side, 2 end stations and 2 pier stations. Then adjacent to it, 4 balance cantilever segmental stations. And then the next one we had 2 times 4 stations for the center span construction. The segment weight was for each section, the average was 55 tons up to 160 tons for the end segments and pier segments. And the rebar cage production in the back, it was on a rebar jig. All the rebar cages were prefabricated and then lifted with we had 8 gantry cranes on rails into the forms. And the capacity of these cranes were about 20 tons. The heavy lift cranes were about 160 tons to move the regular segments into the storage area. Here, an overview of one of these gantry cranes for the heavy lift. The transportation from the casting yard to the site was also challenging. It was over 30 kilometers. And we had about 25 of these special vehicles, transportation mostly during night. And all the structures along the transportation route needed to be load tested. So for all the bridges, because we weren't allowed to overstress their transportation facilities. Here are some construction photos of the precast segmental erection. This is the load test of the launching gantry. Was load tested to 900 tons. Then the erection sequence, again, it started placing a pier segment on there, adjusting the geometry exactly, and then helping with the balance cantilever arm on the side. Again, balance cantilever arm, and then laid on with the launching gantry, the span-by-span construction and the launching gantry with the launching gantry. The launching gantry was then shifted sideways for the next bridges. The following shows some of the construction sequence, an overview from the Hyatt next to it for the precast segmental structure, looking up north, May 21, September 21, end of September 21, and then October 21, and the finished product in January 22. Looking south towards the Infinity Arch in March 21, May 21, and the finished product in January. I want to give credit, of course, again, the owner, Road and Transportation Authority, Parsons, the designer. The contractor for the precast segmental structure was China State Construction Engineering Corporation. Parsons did the construction engineering and inspection. The erection equipment, the gantry, was designed and erected by SDI. The precast producer was China State again. SDI produced also the formworks for the casting yard. And geometry control was done by Sun International. VSL provided for this one the post tensioning, bearings by Fresinet, also the expansion joints, and epoxy supplier Seeker, and the grout material by Comics. Summary. For the Infinity Arch, or the segmental structure, we used about 32,000 cubic yards of concrete, 5,000 tons of rebar, 42,000 meters of PT strands, and 320 segments. For the precast segmental bridges on Cornish Street, 91,000 cubic yards, 15,000 tons of rebars, the PT strands, 145,000 meters, and 1,900 segments. It's also Dubai and Guinness World Records. We also achieved one of these records with one of the safety meetings. We had about 74 nations attending this meeting. And this is also one of Parsons' core values for safety and diversity. So we needed about 50 nations, got 74. Some final pictures after or during construction. The Infinity Arch, and I hope you heard about the weather they had last 2 weeks ago. They got the rain for 2 years in one day. And Dubai was floating and flooded. The infinity arch was okay. Well, here one final picture. Thank you for your time.
One quick question. Anyone who wants to ask you a question?
So what did they do for, for the excessive heat temperature? Specifically, what the mechanism they used, the engineer used to design it? When the infinity arc connected to the bridge here or those files, what was their consideration, or what was the mechanism they used in order to taking care of this heat, excessive heat?
I mean, in Dubai, the heat, it is